Okay, so next we think about a general case of amortization schedule. So consider loan repayments of $1 at the end of each year for n years. So that is annuity immediate. The cash flow is usual n year annuity immediate. So we have time 0 to n, and we have a right angle n here and $1 at the end of each year for n years. So at first you can see that the balance at time 0 is a right angle n. So you can fill out here first a right angle n. So this is 1 minus Vn over I. And repayment amount is always 1, so you can say this is 1 for all n years. What is I1? I1 is I times An. So I1 here is equal to interest rate times balance at time 0. That is 1 minus Vn. So you can fill out here 1 minus Vn. Then what is Pt? Pt is 1 minus Vn. So this becomes Vn. Now, what's the balance at time 1? Remember that there are two methods. The one is retrospective method and the other is prospective method. If we use retrospective method, B1 is obtained by B0 minus P1, previous balance, minus principal repaid this year. So this is 1 minus Vn divided by I minus P1. P1 is V to the power n. That is 1 minus Vn minus I Vn over I. That is 1 minus 1 plus I Vn over I. That is equal to 1 minus Vn minus 1, because 1 plus I is equal to V inverse, then over I. So this is actually equal to a right angle n minus 1. Or if you use prospective methods, you can immediately say the B1 here is the present value of this amount. So this is the $1 for n minus 1 years. So this is a right angle n minus 1. At any rate, you can fill out this as a right angle n minus 1. Now we can recursively fill out these tables, this table. So at time 2, so this becomes 1 minus Vn minus 1, because just n becomes n minus 1. How about P2? P2 is the V to the power n minus 1. And in the same way, the I3 is 1 minus V to the power n minus 2. And this is V to the power n minus 2, and up to 1 minus V for In, and Pn is V. And you can also think about total. The total repayments amount is n, and here the total principal repaid, there should be a right angle n, because this should correspond to the original balance. And also, if you use the formula, that you can also derive the summation of this amount is equal to a sub n. So from this, you can also say that the interest repaid is n minus a right angle n. So one important feature of this table is that this principal repaid, this amount, so this actually grows at the rate of 1 plus I. So 1 plus I is actually V inverse. So actually you can see that this grows at rate of V inverse, or 1 plus I. So this fact simplifies the many questions. So here's one example. So consider a loan with equal annual repayments. So suppose that I is equal to 6% and the principal repaid in the first year is $500. At first, what is the amount of principal repaid in the 6th year? Okay, so in this question, the many quantities are unknown. We only know I and the first year, the principal repaid. We don't have the original loan amount, and we don't have the length of the loan either. So it sounds really difficult question, but if you use the fact that principal repaid grows at the rate of 1 plus I, it can be solved very easily. So by question, you can say the principal repaid for the first year is 500. So you can say that the principal repaid in the second year is 500 times 1 plus I. That is 500 times 1.06. In the same way, the P3 is P2 times 1 plus I, so 500 times 1.06 square. Then, recursively, we can say the P6 is equal to 500 times 1.06 to the 5th power. So that is 669.11 dollars. So this is the answer. So this is the amount of principal repaid in the 6th year. Okay, so now the second question, B. What is the loan amount L if the term of loan is 10 years? So this is also solved by the same property. So P grows at rate of 1 plus I. So L is equal to sum of P1 to P10, because the term is 10 years. So now you know that the P1 is 500, P2 is 500 times 1.06, P3 is 1.06 square, and P10 is 1.06 to the 9th power. So this is equal to 500 times the accumulated value of annuity immediate of 10 years at 6%. So this is because the first payment of the annuity immediate is worth 1.06 to the 9th power, because it accumulates interest for n years, and last payment doesn't accumulate any interest. So you can show that this is equal to this. Then now you can plug in numbers to get the answer. So S right angle 10 is 1.06 to the 10th power minus 1. divided by I. So this is equal to 500 times 13.18, which is equal to 6590.40. So the answer is $6,590.40. So you can find that the property that principal repaid grows at the rate of 1 plus I is very useful to solve this type of questions. Now you can do quiz the 324 4.